afternoon, everyone. Last talk of the day. Obviously, there's the panel afterwards, but that's fine. That'll just be a laugh, I hope. So I'm Trisha. I'm a developer advocate for JetBrains. What that means is I usually come and talk about Java stuff or IntelliJ IDEA stuff. Who's a Java programmer? Great, loads of you, excellent. It's fine, I'm not going to show much Java anyway, so it doesn't matter that much. I also talk sometimes about code reviews. I was here last year giving a talk about how to create a code review system that's going to work for you. Off the back of thinking about code reviews, I started thinking about reading code. And I was working with a colleague of mine, and we started to realize that we just don't really talk that much about the value of reading code. We're always talking about writing it. So, why is my remote not working? Fine, I'll do it the old-fashioned way. Press the button. Great. So I have two small daughters. This is my smallest daughter's favorite book. And this is how we learn language. This is how we learn a natural language. We learn by listening. We learn by trying to speak. And then we learn by eventually reading. My youngest daughter is 1-year-old, so she's not reading this. And eventually, at some point, we will start to write code. The language that we're learning. If you're learning a foreign language, I've been living in Spain for 6 years, so I've been learning Spanish for 6 years. Don't ask me to give a talk in Spanish, it's never going to happen. When you're using something like Duolingo, on the early phases, it will give you things like multiple choice in order to test your ability when you're learning a language. As you progress, you get progressively more difficult ways of constructing the answers, until finally at level 5, you might start free writing your responses. You do not learn to write a foreign language to begin with. However, we're always thinking about writing code. What is the first thing you do when you learn a programming language? You write a Hello World application. You write it down. You would never do that if you're learning a foreign language. You don't write down Buenos dias. It's not the first thing you do when you're learning Spanish. So we're always talking about writing code. We don't value the skill of reading code. So we're always talking about, so obviously we have the programmer, they create the code. The code is the interface between the humans and the computer. We talk about working code. This is the most important value of code. It should be doing what it's supposed to be doing, whatever that looks like. And we talk about readable code, particularly in a software craftsmanship environment like this. We're talking about writing readable code. But again, we're talking about writing readable code. What I want to focus on is this little-known skill of, and how do I read the readable code? What do I need to have in my mind when I'm learning how to read code? So, let's take a step back. Why do we read code? We read code for fun. Good, I'm glad some people laughed. This is from a blog post called Programming Sucks. If you are learning to be a programmer, don't read this blog post. Every programmer occasionally, when nobody's home, turns off the lights, pours a glass of scotch, puts on some light German electronica, opens up a file on their computer. They read over the lines and weep at their beauty. I don't know about you, but I do not do this. Does anyone do this? You don't, no one's putting up their hand. So people, generally speaking, do not read code for fun. We get told we probably should do, but we don't. We read books for fun. We read code to review it. By review, obviously, what I mean is criticize, tear it apart, and find ways in which it is wrong. We read code to find out what it does so that we can use it. So for example, another API or another library. So we're reading it to figure out what on earth is this thing doing, and can it help me do the thing that I want to do? We read code to find out what it does so we can change it. Ultimately, whenever we read code, we're reading it in order to change it, to write more code. That tends to be our focus when we're thinking about reading code. We should be a little bit more focused on reading the code to understand it, to understand the application, to understand the library, to understand the sort of circumstances under which this thing does what it's supposed to do. So what are the problems that face us when we are reading code? Because, of course, code is self-documenting. So there can't possibly be any problems with reading readable code, right? Or reading self-documenting code. This is from the same blog post. This file is good code. It has sensible and consistent names for functions and variables. It's concise. It doesn't do anything obviously stupid. It reads like poetry written by someone over 30. Again, this is clearly not the real world. Code it often does not have sensible and consistent names. It is not always what we would consider good code. It is, in fact, often bad code. When we're reading code, it's bad code. You know why it's bad code? Because I didn't write it. I didn't write it, so I hate it. I didn't write it, so I don't understand it. Or, as is more often the case with my code, I did write it, but I don't remember. I don't know why I did it that way. I don't know what decisions I made. Honestly, I wouldn't write it that way if I was going to write it right now. Another problem that faces us when we're reading code is that technologies change. Something like Java is now releasing every 6 months, which for Java developers is just like an insanely rapid pace. Now, the difference between Java 1.6 and 1.7 was 6 years, right? Now we're getting releases every 6 months, and we're like, what is this var thing that you're talking about? What is a switch expression? What are all these new things which are coming in every 6 months? So we read code which is like more than 6 months old, and oh, this is like ancient legacy code. I don't understand it because it doesn't use the latest version of whatever Java has. On top of that, fashions change. So even if we were writing in like Java 1.3 now, we probably wouldn't write it the same way now that we wrote it when Java 1.3 was the standard. Because nowadays we're a lot more focused on things like immutability, on functional style programming. We can still do those things in an older version of Java. We tended not to do that back then. Back 10, 20 years ago, we were still doing much more procedural programming. We still hadn't really got the hang of object-oriented programming. I'm not sure we've got the hang of object-oriented programming now, but that's not the point. Fashions change. We are moving more towards a more functional, immutable style right now. And when we're reading code, the assumptions that the developers made when they wrote that code are often hidden. So the fact that we did this for business user X because they said they wanted Y on day Z is often hidden by method do something blah. The fact that we had to do it a particular way to work around some weird bug in a library we were using, or to work around some platform thing, or because today's best practice is to use the command pattern, that's not necessarily written in the code. So we don't always understand what assumptions were made when the developer made those decisions. Another reason why reading code is difficult is because people don't read. I myself included. If you've ever tried to organize things like conferences or events, you know, like user group events, you know people don't read. You'll put as the first sentence, this event will not be recorded. And the first comment will be, will this event be recorded? You're like, I know that we're all busy people, and I know that we skim to the important bits. But let's be realistic, people don't pay attention when they read stuff. So when we're reading code, we're not always actually paying attention to what we're reading. So it's quite difficult to absorb what's going on. So ultimately, when we're reading code, I think, I don't understand. Obviously, that means the code is bad because I don't understand it. Or I might decide, well, I'm bad because I don't understand it. I must be stupid. Now, the interesting thing about these two responses is that it might correspond a little bit to where you are on the learning curve. So if you're Googling the Dunning-Kruger effect, you might see a curve like this. And right at the top, right at the beginning, so you could be high confidence and low ability. We all know developers like this, right? High confidence and low ability, but they don't always know that they are low ability developers. I've definitely been there. It's called Mount Stupid if you Google it. And then down here is the Valley of Despair, which is where most of us developers spend our life. We've kind of like, we learn a bit, we think we're brilliant, and then we get a bit more experience and we go, oh my God, it's much more complicated than I thought, and I don't know how to do this, and I will never learn. This is the Valley of Despair. Eventually, you might get up to the Plateau of Enlightenment, or whatever it's called, but I really don't think I'm there yet. So if you might see some code and think it's bad code, and that's probably because you live on one of these two places. The interesting thing about this is you probably don't know which of those two places you live. And then, of course, the conclusion of I'm bad means you live in one of these two places. Again, you might not necessarily know where you are. You might be suffering imposter syndrome thinking you're here, but in actual fact, you're somewhere over here. Okay, so that's an interesting thing. The idea of I'm bad or the code is bad has actually got nothing to do whether you are bad or the code is bad. It's an entirely subjective measure. So fine, doom and gloom. Reading code is kind of difficult, and we all hate it. So that's why we don't do it. We just write code because our IDE does that for us, and we don't have to think about it. Let's have some pragmatic tips on how to actually get better at reading code. Now, this one is the most boring one of all. We have to practice. We absolutely have to practice anything if we want to get better at something. This is from Kathy Sierra's book called Badass, Making Users Awesome. Has anyone read this book? Like 3 people. Are you developer advocates? Yes, you are. If you're a developer advocate, you absolutely must read this book. If you design systems for people, which I hope you all do, you should read this book. After enough exposure with feedback, your brain began detecting patterns and underlying structures without your conscious awareness. With more exposure, your brain fine-tuned its perception and eventually figured out what really mattered. Your brain was making finer distinctions and sorting signal from noise, even if you couldn't explain how. This is your brain learning without bothering you with those pesky details. With more exposure to good quality inputs and closing the feedback loop on whether it is a good quality input or not, you learn more. So in order to get better at reading code, we have to read more code. We have to have a better understanding of like what good code looks like and places where we can learn to read this. So we have to practice if we're going to get better at reading code. And I mean, there's another concept in this book called deliberate practice. I don't mean like we all read code. Of course we do. We have to read code to find out where the bug is to figure out how to fix it. I mean deliberate practice of actually reading the code itself and trying to understand it, and which I'll come over to some more specific tips on that. So where to practice? Obviously, you can practice reading code in your own code base. Now, I know that the code base for an application is not a book. You don't read it from end to end and go, right, I'm finished, I'm done, I understand that. A, you can't do that with an application anyway. B, it's a constantly moving target. So as people are adding things and changing things and migrating things and updating things, your code base is going to be changing. So you are going to be moving with a working target. So you should always be practicing reading code in your own code base. There are certain types of code reviews which are not about criticizing the code, but are literally about what were the changes which went in, what do they look like, why are they there, so I can understand the changing shape of my code base. And this is a very valid thing to do if you want to understand what on earth is going on inside your application. Obviously, you can practice reading with open source libraries and tools and frameworks, especially the ones that you're using. It's quite interesting looking at open source code because you can see some different types of styles. And what I like about that is you get the idea that there are lots of different ways of doing stuff. There is not necessarily one right way. And it's kind of fine to have lots of different ways to achieve the same thing. Obviously, libraries you're using, I mentioned that separate to open source because I know if you're working in a large enterprise, you might be working with closed source libraries, but they're still accessible to you to read them. They're not on GitHub, but they're still something that you're using in your application. Things like coding katas and exercises and stuff can give you some places to practice as well. Now, my most important tip for this is reading is not reviewing. Reading is not trying to criticize it. Reading is not looking at the code going, oh, I wouldn't have done it that way, which we never do we? I wouldn't have called the method that. I'm just going to rename it. No, reading is not reviewing. Reading is not looking at the code thinking, oh my goodness, this is so complicated. I wouldn't have done it this way. I don't like it over here. I don't want to move this here. I just think this should be like this. If we were reading Pride and Prejudice, we wouldn't be thinking, oh, Jane Austen shouldn't have written it like that. I mean, I would have totally swapped chapters 2 and 3. It just doesn't make any sense that way around. That's not what you're thinking when you're reading literature. You're trying to get the message, the understanding from the thing you're reading, whether it's a novel or whether it's an instruction booklet. You're not thinking, oh, I would have put step 1 before step 2. You're just trying to get the meaning of what you're reading. And I want us to have this mindset when we're reading code. Instead of thinking, I wouldn't have done it that way, or I don't think that's the right way to do it, it is what it is. It is the way it is. You have to live in this code base. You have to accept it. Let's read it, not like try and critique it. Okay, then we might be a little bit happier without thinking, oh my God, I totally wouldn't have done it this way every time we look at a piece of code, which is me all the time. So when we're reading it, we shouldn't be trying to judge it. We should be trying to understand it. We're reading it, we're exploring it. We're going to poke around, see what does this bit call. We're going to explore through the code base and have a look at kind of what's happening without thinking about whether it should be doing it that way. We're going to make notes. When I'm trying to learn a new code base or trying to understand what's going on in a set of code, I make a number of different types of notes. So I specifically mark out the difference between notes of discoveries I've made, notes which are questions I need to ask someone, notes which are like stuff I have assumed in order to understand what's going on here. So I kind of separate out some of those notes so I can come back and revisit them later. And draw diagrams. I mean, Simon gave a great talk about the value of diagrams for architecture and design. Often, of course, these diagrams do not already exist in your application, so it's a good idea to perhaps start sketching out some of the diagrams of the current state of the situation. So you can draw diagrams. It doesn't have to be anything formal. You saw the stuff in Simon's talk. Sometimes it's just some boxes and lines on a whiteboard. But that can help us to understand the flow of data, of relationships, of how things talk to each other. Most importantly, you are reading the code, not writing the code. Do not change the code. Do not rewrite Jane Austen. Do not rewrite whatever it is that you're trying to read. Just like focus on the understanding. Code bases have a shape. Code bases, we kind of know this idea that code bases have a shape, and we have to understand what that shape is. But first, I want to talk about Shakespeare. When we studied Shakespeare at school, I don't know, maybe you did, maybe you didn't. Here in the UK, when they made us study Shakespeare at school, one of the things that I distinctly remember is that Shakespeare uses at least two different types of writing. He uses prose for the comedic and lower class characters, and he uses verse for the important characters and for the nobility and stuff. So you can see, purely by looking at the page, kind of the feel for where we are in the play. So the first bit is a bit of informal conversation, and the second bit is like Viola going off on one about whatever it is she's going off on one about. So we can tell, the actor or a reader can tell by reading this, it gives us cues as to where we are in the play and what to expect from the character interactions at that point in the play. Now, code bases, of course, have a structure as well. It's a bit more complicated than just like verse or prose. So obviously we have things like services, modules, packages, layers, patterns. These sorts of things we can kind of hopefully document a little bit with our diagrams, or at least get an understanding of. Things like the naming, the relationships, responsibilities, data flow, build order. The build order, if you look at a Gradle file, or heaven forbid, the XML in a Maven file, might give you a clue as to some of the dependencies in data flow, because the order in which you build various modules is obviously going to tell you what needs to be in place before something else is built. So I can't really give a talk without at least showing a tiny bit of IntelliJ IDEA, because otherwise JetBrains will probably fire me. So I hope not. So yeah, so just as an example, this is a project called Morphia. It's a real Java project. I like to use it for demos like this because it's an open source project. It's like lived-in real code. So it's not like just demo code, which means nothing to anyone. And you can see what we've got is we can tell from here, we have a bunch of different modules. We have our package structure. We can see here what are interfaces, what are classes. The file itself has a shape as well. We've got our fields at the top. We've got various methods. Don't judge it. Like I said, it's real code. Try not to judge it. And so you get a feel for the shape of the code, the shape of the file, and some idea of the structure and arrangement. We can't start understanding something until we start to get a feel for what the shape is. I know loads of keyboard shortcuts for IntelliJ IDEA. I don't know any of them for PowerPoint, and I always get them wrong. OK, so code bases have a structure. Code bases have a dialect. This, I think, has been one of the most important things for me to understand. A particular code base has a dialect. It might meander a little bit as well. But by dialect, I mean that it has a particular, you might call it standards, but it has a particular tone or style. So let's go back to Shakespeare. You can sort of tell by reading this that Shakespeare, if music be the food of love, play on, give me excess of it, that surfeiting the appetite may sicken and so die. I totally should have been a stage actor. That would have been my thing. OK, fine. I can kind of understand that and get a feel for this being Shakespeare because it looks kind of, Shakespearean. Let's go further back. Let's look at Chaucer. I am not going to read this out because I don't understand any of it. This is written at the end of the 14th century, obviously before spelling standardization in English. And when I see this, instead of sort of seeing the poetry, so getting a feel for what the poem is all about, all I can see is, well, that's not right, and that's not how you spell sun, and I don't need an E there, but I do need an E there. And what I want to do in order to understand this is I want to correct it, or at least change it to something that I can understand in order to understand it. But how can I change it into something that I can understand if I don't understand it? And this is what we do all the time with code. We often refactor something in order to understand it, which kind of makes perfect sense for us when we're doing it at the time. But when you look at it with English, it makes absolutely no sense to do that. Why would you change something before you know what it's supposed to do? Okay, so if you're going to understand Chaucer, don't correct it first. Try and accept it. Try and live with it. Try and read it. You can read it like with the translation side by side if you want to, but don't go ahead and change it in order to understand it, because you're going to take away everything that makes it Chaucer. So code bases have a dialect as well. And I would say in the Java world, probably the biggest influence in this would probably be the age of that code. Like I said, it's partly about what features were available in the language at that time, but also about fashions and styles. Like older code will be more procedural, probably. More modern code will perhaps be more functional, will have a better understanding of immutability. And so age will influence some of that dialect. Obviously, things like the libraries you're using, the frameworks will also have a big impact, particularly something which is a very opinionated framework will force you to write in a particular way. So if you are trying to write something which is springy and you don't use the Spring way, you're going to find it much more difficult to understand how Spring works or to get the application to do what you want it to do. So things like the language libraries, age, patterns, standards, these are going to impact the dialect of your application. And the code shape will also as well. So what I'm trying to say is that with the code dialect, try and understand what the dialect is. Don't try and change it. Try and just understand it, accept it, work with it. I want to talk a little bit about the concept of false friends here. So when you're learning another language, there's this concept of false friends, whereby a word sounds like something familiar, and so you think it's something similar to something you know, but it's not. An example is, in Spanish, embarazada doesn't mean embarrassed, it means pregnant. These are two very different concepts, and something I learnt while I was pregnant in Spain. So in technology, we have the idea of false friends as well, I believe. Think about MVC as a pattern. Okay? Every application that you've worked on that has a model view controller will have had a different model view controller concept, I'm sure of it. Some of them have controllers that literally control everything. Some of them have views which are very anemic. Some of them have views where most of the business logic is in there. So the idea of MVC is not really... The idea of design patterns is it's supposed to give us a cue as to what to expect from the design of your code. But often it can trick us with this idea of false friends. I come here with an idea of what MVC looks like, when in actual fact the MVC in my application is a different flavor of MVC. But I keep trying to force my understanding onto what is actually there. And so I'm either going to write code that's not right, I'm going to misunderstand what's happening here. This conflict is going to cause problems. So I need to be able to try to put aside my preconceptions and try and understand what's actually there, instead of trying to inflict my preconceptions on what's there. So false friends. Next, code is not linear. We kind of know this. This is like, I don't know, a lot of you look like you're more or less my age, so you probably understand this. When we first got the internet, and we started reading hypertext, and you got this, and you got all these things you can click on, and that's really great, and you go burrowing down. I was literally reading about the Peninsular War, don't ask why. And I was burrowing down, and you end up with a stack here, and you end up researching Silesia. You're like, how did I get here? What was I trying to find out? Because, hypertext is a non-linear medium. Obviously, tools came along and they kind of improved this for us. So instead of having a stack, we now have 15,000 open tabs that we will never read. Wikipedia itself can make this a little bit easier, allowing us to hover over, get the sort of TLDR of that thing, so I don't have to click on it. So when you have a non-linear narrative, the tools can help us, because humans are obviously going to work in a reasonably linear way, except for, in case you hadn't noticed, I don't work in a very linear way. But we work in a fairly linear way. The tools can help us process non-linear data. So obviously, this is where something like an IDE is going to significantly help you to navigate your code base. I'm going to demo some navigation tips in IntelliJ IDEA for obvious reasons, but all good IDEs will support the same kind of thing. I'm not saying you have to use IntelliJ, but if you do, mention my name so I can get a commission. Navigation. Where am I going to go? So normally, the IDE has a bunch of buttons and stuff and tabs and things around it. I turn all of that off because it's just distraction. It just gets in the way. Also, you should not be using your mouse. If you're using the mouse, you're doing it wrong. turn on a plugin called Key Promoter, which will flash something up every time you use the mouse and tell you to use the keyboard shortcut. It is so annoying that you're forced to learn the keyboard shortcuts. OK, so navigation. Firstly, I can navigate to a class control, and the shortcuts will appear at the top. And so I'm going to go to something like, what do I want to find? Default query factory. And I can, obviously, I can click through to find something. But like I said, don't use the mouse. That's not what the mouse is for. I can use keyboard shortcuts like Control B to navigate to the declaration of something. Much more useful for me is Command. Let's see if I can remember. I can't remember what the names are. Just my fingers know what to do. Except for when I've been using the Mac for 2 weeks and I can't remember the Windows. So use Control Alt B to drill into the implementation of this. Or if you've got multiple implementations, you use Control Alt B, then it will say, which one do you want? Do you want this anonymous one in the test, or do you want the default query factory? So I can navigate down there. So I should be using like the navigation tools to navigate to where these things call in. I can use things like, I'm going to use Alt F7, no, not Alt 7, Alt F7 to find usages of something, because if I'm changing a method, then I'm going to want to know, like, what's calling this thing, what are the impacts of doing that sort of thing. What else can I do? I can navigate forwards and backwards using Control, Alt, and arrows. And I can do things like, one of the useful things in the most recent version of IntelliJ, let me just open this up a little bit, is Control-Shift-E, will give me all my recent locations. So not just files, but like the bits of code that I've just been looking at. So if I find myself in one of those like wormholes where I've just kind of burrowed down here, I'm like, what was I looking at before I got here? So I use like Control-Shift-E for recent locations, and I can go back to some of these locations. I'm like, oh, OK, yeah, I was in this test. That's why I ended up in this position. I don't want to spend too long on this because it's basically like, either you care, in which case you can go away and have a look at this video, or you don't care, in which case you want me to shut up. So, Control-Shift F5. No, what is the keyboard shortcut? Shift F5. Fine. OK. Code is meant to be run. So we talked about the fact that code sits between the programmer and the computer. It's not just something for the programmer to read, although we do have to think about the fact that the programmer is a customer of that code. So code is meant to be run. And in which case, in order to really understand it, we should probably run it. This quote is from a book called Everything Bad is Good for You, How Popular Culture is Making Us Smarter. It's great because it says if you play computer games and watch telly, you're getting smarter. So I'm totally on board with that, and I want to tell everyone about it so I can read more, I can watch more telly and play more games. If you don't think, this is talking about playing computer games, if you don't think about the underlying mechanics of the simulation, even if that thinking happens in a semi-conscious way, you won't last very long in the game. You have to probe the process. So when you're playing computer games, you have to sort of vaguely reason about like what's going on under the covers. You kind of have to have a feel for like the flow and the running of the game. And of course, the same thing is true of when we're reading code. We can't just sort of read it and implicitly understand everything. We have to probe it. We have to sort of reason about it and kind of like poke it and see what happens. So in order to really understand something, we need to run it. And obviously, the IDE has a bunch of tools to do that as well. I will just do a quick thing, because there's a couple of tools in the IDE, which I believe is in other IDEs as well, which make things much easier. For example, obviously, you can debug stuff, and everyone knows how to use a debugger, right? I know things are much more difficult when you're debugging like microservices, apps like in the cloud, like in production. That's a bit more tricky, but we should be able to debug some simple bits of code. So if we're trying to understand a library that we're working with, we can sort of spin something up and run it in debugger to sort of see what's actually happening at that point in the class. So let's step over. So if we're in this is where we started looking at, so this create query class. So if I was looking at this particular method, I might be thinking, OK, this is all well and good, but at what point do I get here? What is the state of things when I'm here? So my debugger will tell me, in order to get to create query, first it comes through find, create query, new query, create query, and create query. I have some reservations about that stack trace, but I'm here not to judge. I just have to accept it the way it is. So I end up, this is the stack trace as we are in the code, and I can see the value of various variables. IntelliJ also quite usefully sort of tells me what's going on in line as well, so I can see that query is null, so I don't have to worry about it, or I have to worry about it a lot, I'm not really sure. So I can see my variables down here. I can also add watch expressions, so I can say like this dot, I don't know, there aren't any variables in this one, but I could kind of put some things in here. So I could say int I equals, I could just say 1 equals 2, and it should hopefully say no. So I can kind of put some stuff in there to figure out what's going on. You can't really see that at the back, can you? The other thing about running things inside a debugger is that you can change the variables as well, which is something I wasn't really aware of until I had to debug some very complicated stuff. So you can, for example, you can set these values as well. You don't just read them. You can kind of set them to whatever you want. So I can say set value. And I can change these values and then run things from there. So I can say, if I don't have a test that duplicates the situation that I want, I can like poke the values I want in real time using the debugger, using my tools to kind of get a feel for how it would behave under certain circumstances. Obviously, it's not a replicatable test if you do that, but it is a good way of sort of understanding what does the code do under certain circumstances. There's a bunch of other stuff I could show around here, but like I don't think we have a lot of time for that stuff. So debugger, Alt F4. Nope. Yes, terminate. No, you know what I've just done? I've just closed IntelliJ IDEA. You're so smart, Trish. Right. Let me reopen that. Oh, yes, I do want to update in the middle of a live demo. Yes, please. Please don't update. Oh, you piece of shit. Love live demos. Great. We won't be showing any more IntelliJ IDEA right now, but if you do want to download the latest thing, go ahead and do that. Right. So run code to fully understand it. Great, because I have no more demos around that. That's fine. Oh, but there is a feature called evaluate expression, which allows you to paste like arbitrary bits of code in while you're debugging, and so you can kind of like evaluate what circumstances, what things are doing at particular times and stuff. So again, it's a good way to sort of test theories of what's going on while you're reading the code to understand it. If you absolutely must write something, write tests. So we've just talked about like poking some values in. We could write some more structured tests to sort of have a hypothesis as to what something does. This is from the same thing about playing games. The game scholar, James Paul G., no relation as far as I can tell, breaks probing down into a 4-part process, which he calls the probe, hypothesize, reprobe, rethink cycle. So he's talking about when we're playing games, especially modern games which don't have like these kind of set stories, we have to sort of make a hypothesis, like do something, see if we die or not, and then go back to the beginning. And this is kind of the same as when we're trying to understand how the code is working. So this sounds suspiciously like testing. So let's create a hypothesis, let's make a test which tests that hypothesis, let's run it, and then let's re-hypothesize based on the results of that. So if we really want to understand something, if we absolutely have to write something to figure out what's going on, let's write a test, let's not change the code. If you really, 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 really must change the code, because sometimes that's the only way to figure out what is this doing, what does it do under these circumstances, then throw it away. Do it on a branch if you really feel like you have to keep it. Do it on a branch or stash it or shelve it or whatever so that you can feel warm and fuzzy that you didn't throw away all that hard work. But honestly, throw it away. Write the code, do the hypothesis, do that refactoring that you think is going to make stuff better. But if you're in the learning process, the I'm trying to understand code process, if you write something, throw it away. If later on you decide that refactoring is a really good idea, fine, pick up that tech debt ticket or set aside some time to do the writing. But when you're in the process of learning, of understanding, try not to conflate the two concerns of I'm creating something, I'm writing something. I can't see what that says. Does that say 10 minutes? Thank you. Don't conflate the process of I'm creating something versus I'm trying to understand something. So let's try and keep them a bit separate. Not all knowledge can be codified, and this has been covered quite a bit throughout today as well. So not everything that was going through people's minds when they wrote the code can be written in the code. Like even if we wrote comments in our code, which apparently it's not fashionable to do that these days, even if we wrote comments in the code, we couldn't possibly capture everything, every decision that we were making in like the lines of code that we are reading there. So I have a quote, obviously I've got loads of quotes. It may or may not have helped Anathema to get a clear view of things if she'd been allowed to spot the very obvious reason why she couldn't see Adam's aura. It's for the same reason that people in Trafalgar Square can't see England. If we're looking at lines of code, it's going to be very difficult to have a feel for what is the architecture, like what is the big picture, what's the business domain, what are the big picture things that are happening here. We can't really see that when we're looking at the code, and that's fine because Simon was talking with his diagrams. There was like 3 or 4 levels of diagrams, which are like big picture all the way down to this is how to get here, and at the lines of code, we can't capture everything and write it down, even if our code is self-documenting and clean and everything. So in order to really get a feel for what's going on, we're going to have conversations with people. I know, we're developers, we don't like talking to people. But we're going to need to talk to people to say, look, I was reading this code and I think it does this, or these are the questions or assumptions that I wrote down while I was making notes. Does that seem sensible? We can be asking our peers or leads or architects or whatever, or we can be asking the business, look, do you really expect it to be working this way? And we need to be having actual conversations with people. I do recommend that some of these things perhaps should be written down somewhere as well, so other people don't have to go through the same process as well. But it's not mandatory because I know it's reality that documentation does get outdated very rapidly, and if the documentation is out of date and out of sync, then it can be more confusing than if we didn't have any. But we do have to be able to have those bigger conversations of, look, this is kind of what I think it's doing. Can you tell me why it's doing that? Or, can you tell me what's going on? When it gets deployed to production, for example, what's different? So, just to summarize those tips. Practice. We're not going to get better without practicing this. And I mean deliberate practice of reading code to understand it, to accept it, not reading code to find this bug or to critique it. Reading is not reviewing. Reading is for understanding and learning. Code bases have a shape. Code bases have a dialect. Let's kind of learn what they are and learn to live in those constraints. Code is not linear. Code is meant to be run. If you absolutely must write something, write some tests. If you must change it, throw it away. And not all the knowledge is codified, so not all the knowledge is going to be there in the code. You're going to have some other conversations with people. So when we're reading code and we don't really understand it, which for me is like all the time, I shouldn't be thinking, right, I don't understand it, so the code is bad, or I am bad. It's just accept the code. It is the way it is. I will understand it by learning more about it. I don't have to judge it. I don't have to judge the code or myself. I need to learn to accept it and to live with it. I'm grizzly and grumpy and grouchy and grumbly. I've not been called lovely before. This is another one of, this is from my elder daughter's favorite book, The Giant of Jum. It's about, we have to learn to accept the situation that we're in. Let's not be judging stuff all the time. It just makes us really miserable. So let's kind of be nice about some of this bad code, because it's probably not as bad as we think it is. In conclusion, code is for reading. Obviously, code is read by the computer. That's kind of what it's supposed to do. But it's also to be read by programmers. Indeed, the ratio of time spent reading versus writing is well over 10 to 1, says Uncle Bob, so it must be true. We are constantly reading old code as part of the effort to write new code. Therefore, making easier to read makes it easier to write. So once again, when we're talking about writing readable code, we're talking about reading it in order to write it. Now, I know, I'm not disputing the fact that our job is to write code. If we're developers, if we didn't write code, that would be, we might get fired. But we need to be able to understand the fact that reading code is a skill in its own right, and the output is not always to write more code. So instead of always looking at this process of outputting code into the computer, the writing code, let's look a little bit at this skill of learning how to read the code, of learning how to live with a code. My fingers, said Elizabeth, do not move over this instrument in the masterly manner in which I see so many women's do. They do not have the same force or rapidity and do not produce the same expression. But then I've always supposed it to be my own fault because I will not take the trouble of practicing. It's not that I don't believe my fingers are capable as any other woman's of superior execution. We're not going to get better if we don't take the time to practice. And I think we need to consider reading code as a skill in its own right, which must be practiced, must be learnt, and must be valued, instead of us always purely valuing the output of writing the code. We need to understand there's an input of reading the code and getting better at that. Thank you very much. So I've got, this page has a list of links, a bunch of stuff that basically everything I Googled in order to put this talk together. The slides are up here, and when the video is available, the video will be on here as well. So shockingly, I think we've actually got time for questions.
Yes, I think we do.
This never happens. Questions? Everyone wants coffee? Great. Oh, is there one at the back there?
Yeah, we have one at the back there.
Hello.
Hello.
How you doing? As far as I guess my question is, when you're reading, where do you actually start? Especially as I feel maybe as a beginner, like you might not even know where to even start reading. So, do you have any advice as far as like where do you even start? Which class or function?
Yep, absolutely. It's a great question. So the question is, fine, but I'm like a total beginner at this, or even if I'm not a total beginner, where do I start to learn? Where do I start reading the code? It's a fantastic question. So there's actually someone else who's answered this question in a whole talk of her own. It's a fantastic talk. The link is on here. I highly recommend seeing that. It's a whole set of tips for the actual act of reading. Where do you start? How do you use the debugger? How do you do this? How do I do that? She recommends that you start with like the main class. So if there is a main class with public static void main, or if there is like a start or an init, kind of literally like start there and like drill down. The advantage of starting there as well is that even if you don't have tests, because not everything's got tests, you can use that to actually run the application as well. So you can start from the running application. So that's definitely one place to start. When I'm trying to understand a particular piece because I need to do something, like I'm trying to add customer functionality, I might start by looking for a class called customer, and I might start with the business domain and look outwards from that. But if you're trying to get a feel for the whole application, starting with the entry point, like the main method, is probably the best place to start. Another question at the back.
So in a similar vein to the previous question, if you were teaching a child to read, you wouldn't start them off with something like Chaucer, right?
Right.
So my point being is that if we want to learn to read code better, and we also want to learn to read code in an effort to write code better, what kind of code do we start with? If we start reading absolutely awful code, we don't learn how to read code well or how to read good code.
Yeah,
that
so
makes sense.
I was hoping someone wouldn't ask that question. Yeah, so the question is like, what do we start? If we're teaching someone how to code, how do we start them off with something that looks the shape we want them to learn in a way? So yes, in fact, Kathy Sierra covers this as well in the book, and she talks about how the idea of deliberate practice and the quote that I had of your brain learning with feedback is all about seeing examples of the thing you want to emulate. So you want to see code is the way you want it to be. So clean code, software craftsmanship type code with good naming, and preferably something with like short methods so it's easier to understand. I mean, if we were teaching beginners how to code, then I would want to find open source code that looks like that, or some code training examples which kind of follow that pattern. The pitch for this talk is really like, I assume that you are an enterprise developer and you have to kind of live within the world that you live in, which means that as much as we want to clean up the code that we live in as we go along, but I would like us to start reading the code that is the shape and the dialect that we're living in, the real world that we live in right now. And whether that's like bad or good, I'd like us to work within that dialect. So even though we could be replicating bad patterns maybe, I would like us, I believe a code base with consistency is better than something with a mishmash of styles as people come in and inflict their own ideas on the code base. So even if you're working within a code base which is not really great, I would like to see that consistently applied across the whole code base. So you'd be learning like not great style, but in terms of applicability, I think it's probably better.
So would you believe that the act of reading in itself is beneficial regardless of the source?
I do believe the act of reading is beneficial regardless of the source. But I was thinking specifically in terms of you have to live with the code that you've got. And mostly we don't tend to think of untidy code. We tend not to think, oh, this is fine, I will continue to write untidy code. We tend to think it's not great code and we would like to do better. But I want us to get away from this constantly beating ourselves up about the fact that it's not good enough. And I want us to just accept it a bit more and just kind of work within that.
Thank you very much. Cheers.
Okay, I think that's all the time we have. So thank you very much, Trisha.
Thank you.